Hi, I will be helping you today with modeling quadratic equations. A model rocket is launched from ground level. Its height h meters above the ground is a function of time t seconds after launch and is given by the function this. What would be the maximum height? Let's sketch this here. This is a x-axis and y-axis. You will have a parabola this way with a maximum point, and y is going this way because you have the coefficient of t squared is a negative number. Write the equation. H equals negative 4.9 t squared plus 68.6 t. You're looking for the maximum height. In order for you to find the maximum height, you need first to find the axis of symmetry, this point, or after how many seconds will the parabola reach the maximum height. The axis of symmetry. In order for you to find the axis of symmetry, you need to find A and B. A is the coefficient of t squared, which is negative 4.9. B is the coefficient of the x or the t, which is 68.6. The formula for the axis of symmetry, x equals to negative b over 2a, and that is x equals negative b over 2a. Substitute. B is 68.6 and a is negative 4.9. Get your calculator. Negative 68.6 divide by, make sure you don't multiply under the division, but instead you put them in parentheses. 2 times negative 4.9 equals to 7. Okay, you take this 7, so after 7 seconds, the parabola will reach the maximum. You take this 7 to find the maximum and substitute it in the original function. You have h equals negative 4.9 times t squared plus 68.6 times t. And inside the parentheses you have the value for t, which is 7. Get your calculator. You have negative 4.9 times 7 to the power of 2. We know it's say 49. Well, let's put it this way: 68.6 times 7 equals to 240.1. 240.1. So the height, the maximum height, is going to be 240.1 after 7 seconds, and the closest answer here is D, 240, not 241, because the when you round it, it's going to be close to 240. And also here, they needed to the nearest meter attained by the model, so this is the nearest meter. Another way to solve this problem is using the graphing calculator. You graph the function and find the maximum point. You graph this function. Of course, h is the same as y, t is the same as x, negative 4.9. And of course, you're not going to use the t in the calculator because the t doesn't have any value in the calculator here. Instead, use x squared plus 68.6x. Graph this function. Okay, it's out of bound here. You zoom your zoom 0, your answer. Okay, I see there's a maximum here. You go to second trace, max, go to max. Where is your left bound? It's, you see the cursor is blinking to the in the left side. You click enter, and then you move your cursor to the right, all the way to the right bound of the maximum. I'm just going to make it here. Can you see that here? Click enter, and then you go guess where is your maximum. My maximum is somewhere here. Enter. So the x-axis is 6.999, which is the same as 7 seconds, and the height 240.1, and that's the same thing we got. Your final answer is 240. There are two ways to do this one: algebraically this way and the graphing calculator. Work well.